point Q is equal to what? Minus Py. Okay, that's a counter moment. So the next thing we're going to apply, we're going to do, and I think you all learned this in math before. Okay, we're going to apply what we call the elastic curve. Okay, elastic curve equation to relate bending moment to relate bending moment to deflection. Okay, to relate bending moment deflection. So what is this elastic curve equation? If I write to you, you say, hey, I've seen this before. So it's basically Young's modulus multiplied by second moment of area d squared y over dx squared, and this is equal to moment. Okay, so this is what we call the elastic curve equation. Okay, so by focusing on this elastic curve equation, right? By focusing on this elastic curve equation. So now if we were to write out d squared y over dx squared is equal to m divided by ei. Okay, and then we know that the moment, right? We know that the moment is equal to minus py. Okay, so we know that this is in fact equal to minus py over ei. Okay, so basically I just immigrate this equation down here. So if we were to rearrange this equation, what do we get? We get d squared y over dx squared, right? Then we have plus p over ei multiplied by y. The whole thing is equal to 0. Okay, so this is our equation 7. Have you all seen equation 7 before? Anyone? I think probably 2ZZ03 or something like that, right? Right. So what do you call an equation like this? Anyone? Can you remember?
ODE, I think.
ODE. Yeah, it's second order differential equation. Okay. So this is known as a homogeneous second order differential equation. Okay. So if we were to look at the parent function, okay, and basically is d squared y over dx squared is plus by a dy by dx, okay, plus by by is equal to 0. Okay, so this is the general parent function that you see over here for homogeneous second order differential equation. Okay, so by looking at equation number 7, okay, we are going to let small p, okay, not big P. This is capital P. You can see the difference, right? This is capital P. This is small p. Okay, so small p, the p is the round part of p is written on the line. So they are not the same thing. Okay, so we are going to let small p is equal to square root okay, big P over EI. Okay. Okay, we're just going to let it be that form. Why? Because it will ease our writing of the solution in its final form much more convenient. Basically, that's it. Okay. So therefore, equation number 7 okay becomes a squared y over dx squared. All right. Then we have plus small p squared, right? Small p squared multiplied by y will be equal to 0. Okay. Now, what we can see over here, okay, I want to draw your attention to the homogeneous second order equation. Okay, so we know that over here, if we were to find the roots, okay, let's say we're going to determine the roots, okay, will be equal to minus a plus minus a squared minus 4b, right? And then the whole thing divided by 2. Okay, the whole thing divided by 2. So if I were to spread things out, we have this as equal to minus a over 2 plus or minus square root of a squared minus 4b divided by 2. Now, based on our equation over here, okay, based on what we have over here, we have d squared y over dx squared, yes, but we don't have what? We don't have dy by dx. So this is equal to what? 0. Okay. So when the a value, this is equal to 0, right? You cannot have minus 4b. Okay. So therefore, the roots, or therefore, we will get, therefore, the solution or the roots will be in the imaginary domain. Okay, right? You can, if you press your calculator, minus 4 square root, if you turn on your calculator, you put square root of minus 4, they tell you math error. Okay, there's no real number. So in this case, we are going to have the solution. Okay, the solution will be based on complex conjugate roots. Okay, we're going to have complex conjugate roots. Okay, so the general solution, I'm going to copy this whole thing to the next page so you can see more continuity. Bear with me. Do apologize for this. Okay, so complex conjugate roots. So the general solution right? We will have a general solution, and the general solution will be y as a function of x will be equal to e minus a over 2x, or minus ax over 2, okay, e minus ax, the power of minus ax over 2 bracket C1 sine square root a squared minus 4b divided by 2 x plus by C2 cos square root a squared minus 4b. The x term is outside the square root and divided by 2. So I believe you all are very familiar with this. Okay, this is basically your math that I think you learn in your second year. Okay. So coming back to our equation, so we know that's the general solution. Okay. So if we look at this equation over here, right, what we know is A, right? We know that this term, we know that what? A, okay, looking at this equation over here and relating to our parent function, we know that A is equal to 0. Okay, so if A is equal to 0, this will be equal to what? 0 multiplied by x multiplied by 1, e power 0 is equal to what? 1. Yes or no? Right? And then over here, so if we know that A is equal to 0, let me put this form into our equation. Okay, so general solution for equation 7. Okay, so I'll put this form. Okay, I'll still put this form. And we're going to put it over here. Right. Right. So we know that A is equal to 0. So when A is equal to 0, these are also equal to what? 0. These are also equal to what? 0. Okay. So what we have now is y as a function of x, e to power 0 is equal to 1. Right. So bracket C1 sine square root minus 4b over 2 x plus by C2 cos, okay, square root minus 4b over 2x. Okay, so if we introduce the minus the 2 into the square root, right? I will not skip steps. Okay, I want you to see this properly. You have C1 sine. Now I bring the whole square root, so minus 4 divided by 4b x plus by C2 cos square root minus 4b over 4x. Okay, so what we have is C1, okay, C1 sine, right? 4 divided by 4, we could be 1 square root of minus bx plus by C2 cos square root of minus bx. Okay, and we already know that it's under complex conjugate roots, so we can write y as a function of x is equal to C1 sine square root b x plus by C2 cos square root b x. Okay, so now we know that b, right? So we know that, so if we go back to this function over here, okay, if we go back to this function, so let's focus on these two terms now. Okay, let's focus on p squared y and by. Okay, so we know that p squared is equal to b. Okay, we know that, we are aware that p squared, note that p squared is equal to b, right? So I'm going to call this equation number 8. Okay, equation number 8. So when that's the case, equation number 8, will be equal to y as a function of x is equal to c1